All right, so key idea number 2 for quantitative reasoning is making sense of when things are increasing, decreasing, and constant. So first of all, increasing means that something is going up, decreasing means that something is going down, and constant would mean that something is staying the same. It's not changing at all. So we use these words to describe how values are changing, especially in relation to each other. So when one thing is increasing, is the other thing also increasing? Is it actually decreasing? Or is it not affected at all? Is it staying the same? In which case it's constant. For quantitative reasoning, it's especially important to consider how those quantities are changing, increasing, decreasing, or constant, but also what that means in context. So again, using the labels to make sense of what's actually happening in the story based on when those things are increasing, decreasing, or constant. So let's take a look at an example in a table. So using our labels, we've got weeks and the amount of money in an account. So if we look at just weeks, we're going from 0 to 1 to 2 to 3 to 4. We can see that whole time our values are going up, starting at the lowest 0 and then slowly rising up to 4. So we would say that those values are increasing. And I'm not going to write out the whole world, or I'll just write out ink. How about the money in the account? So it starts off at $300 at 0 weeks, and then after 1 week, it goes to $150. So that's going down in value. So we would say that that's decreasing. Continuing on from week 1 to week 2, we can see that it's $150 and then it's $150. It didn't change. It did not go up or down. It stayed exactly the same. So that means it's constant. And then from weeks 2 to 3 and 3 to 4, it goes from 150 to 200. And then from 200 to 300, that whole time, it's increasing. So if we wanted to relate this table, or at least the information in this table, I guess I should say, we would say that as the weeks increased, the money in the account decreased, stayed constant, and then increased. Again, it was decreasing from week 0 to week 1, constant between weeks 1 and 2, and then increasing from week 2 to week 4. With that said, let's take a look at the graph so we can see that it's titled traveling by car. So we're in some sort of car. Of course, it's always important to pay attention to our labels. So our x-axis here is labeled the time in minutes, and our y-axis is labeled the distance from home in miles. So that's pretty cool. Again, in this graph, we don't have a scale, so we don't have any numbers to refer to, but that's okay. We can still get a general idea of what's happening here. So starting at the beginning, we usually want to read our graphs from left to right. So when x is 0, in other words, when time is 0, in other words, before anything's happened at the very beginning, we can see that the distance from home along our y-axis is also at 0. So they start out at home. And then we can see it slowly go up and up and up and up. In other words, even though we don't know what these exact values on the y-axis are, we can see that it is in fact increasing. So as we're increasing time along our x-axis, we're also going up and increasing our distance from home along the y-axis. Until at least we get to this point, and then we can see it flattens out. Well, what does that mean? Well, time is still increasing, right? We're still carrying on from left to right along the x-axis, getting further and further along in time. So time is still increasing, but now the distance from home, that y value, is constant. It's not changing. It's staying at the exactly same location. So this is what a constant section of the graph looks like. And last but not least, we get to this section where we can see it's decreasing. Now, it's worth noting time is still increasing here. If we're reading from left to right, our time is getting bigger and bigger and bigger. But our y value, our distance from home, which is what this is really talking about, starts up here and then it goes down, down, down all the way to 0 when they're home again. And in fact, it's worth noting this section of the graph, when it was increasing, it took a pretty significant amount of time. They were increasing gradually, versus this time when it decreases, we can see that that's taking a much smaller amount of time. Again, we don't know exactly how much because the graph is not labeled with a scale, so we don't have any numbers to use to get exact values, but we can still just look at the graph and approximate that this is more time to increase than it was to decrease. So they decreased that distance from home very quickly. So thinking about what could be happening in this story, again, they started at home, their distance from home was 0, then they increased that distance from home, so that must mean they're traveling away from home to some place. Then their distance from home is constant, so they're staying the same distance away. Now, this could mean that they've stopped somewhere, and so that's why they're staying the same distance away. Maybe they're grabbing takeout, maybe they're going to the store. But it could also just mean that they aren't getting any further away from home. So, like if you're driving in a circle, you're staying the same distance from home. We don't have any information in this graph to be sure of whether they're actually stopped or not. All that we know is that their distance from home is not changing. Their distance from home is constant at this point. So they aren't getting any further away from home and they aren't getting any closer until we get to this part of the graph. This part of the graph is decreasing, so that means the distance from home is decreasing. In other words, they're getting closer and closer to home, and again, pretty quickly. So they go away from home and kind of take their time. Then we pause and stay the same distance from home, and then we're decreasing quite quickly. We're rushing home at the end there. So that's how we might interpret this graph. However, again, the labels are super important. So this was talking about the distance from home. If instead it were talking about the distance from work, this would tell a different story. So this would mean that you're at work, you start leaving work, maybe you're headed home, and then again, we get to this constant part where you're not getting any closer or further from work. You're staying the same distance away from work. Maybe this is where your home is. Maybe it's this amount of distance from work. And then we see it decrease again as the person is getting closer and closer, this time to work. So now it's distance from work. So now 0 would represent being at work versus when it was distance from home, 0 represented having no distance from home, in other words, being at home. If instead we change that label to say distance from work, then 0 would mean no distance from work, which means that they're at work. And if we change it even more drastically to say talk about the speed in miles per hour, let's make sense of what that would mean. So that would mean that again, it starts off at 0. So a speed of 0 doesn't tell us anything about where they're located. They could be at home, they could be at work, they could be somewhere in the road in between, they could be at a school or at the store. We have no idea. What we do know is that their speed is 0. In other words, the car is stopped. Then it starts increasing the speed. So the car's going faster and faster and faster and faster and faster and faster and faster until it gets to a certain speed, and then it's constant. Somebody said this could be kind of like cruise control, where you're just keeping the car at the same speed. So again, this doesn't mean the car is stopped because we're talking about speed. So what constant means is that the speed is not changing because the y-axis is talking about speed. As our time continues to move forward and increase, the speed is not going up, it's not going down, it's staying exactly the same. So they're at some speed this whole time. That's not stopped, because if it were stopped, that speed would be 0 and we'd be down here. We don't know exactly what the speed is, but we know they're staying at that same speed for this entire portion of the time. And then for this last portion of their time, their speed decreases very quickly. So that means they're probably putting on the brakes and slowing down until they get all the way back to 0. So they came to a complete stop. Maybe there was a stop sign or a stoplight. All right, so hopefully that helps you make sense of increasing, decreasing, and constant. Here's a few questions you can use to check your understanding on this key idea. Think about how you can tell whether a quantity in a table is increasing, decreasing, or staying constant. Think about where you look and what you look for. Same for a graph. How do you tell if it's increasing, decreasing, or constant? Where do you look and what do you look for? And then, of course, also consider how are you going to use those labels to interpret what those changes in the table or graph actually mean about the changes in the relationship between the quantities involved. How do you actually tell the story and talk about what's changing between the things that are labeled on your table or graph. That's really important.